So solving by substitution, you should think, right, there's only three. We're going to study three, that's it. Graphing, substitution, and today we're going to cover elimination. And so I'm going to grab a new piece of paper and just redo it. So here we go. The first thing I would suggest is if you have, I still always want you to think independently, right? I don't want you to always follow step by step. As long as yours is algebraically and the arithmetic is all right, there are various ways of doing this with some tweaks, right? If you have this system and you have fractions, that was the video I posted, right? When the system went down, I had an example in your booklet that deals with fractions, okay? And you're wanting to do substitution. The first thing you should do is look at all of the denominators. And I basically do this. This is how I show what I'm doing here. I'm creating an equivalent equation. I'm making it look different. So I look at the denominators, and the lowest common multiple of all the denominators is the one that wins. If you're like, what is a multiple again? Well, I'm thinking of 2, right? 2, 4, 6, right? You keep going, and then you do the same thing with 3, 3, 6. Oh, 6 and 6, that's common, right? That's the lowest common multiple, right? The LCM is 6. So I will multiply. No need to do the denominator for 1 because it is just 1. Any number will work for it. So you multiply the whole thing by 6, the whole equation, every single thing, every term. So 1/2 times 6 is just 3x, right? And then here you have to be careful, 2/3, right? You can either go 2 times 6, that's 12, divided by 3 is 4, right? And watch the sign, right? It's a positive, so no worries there. So that's 4x, like that. And then the other one, the last one is 1 times 6 is just 6. So you have effectively created, it's the exact same equation, but it now looks different, okay? And I will call this 3. We called this one 1 and 2. Those are the original. And now we've created another one. I do the same method, the same steps with this one. What's my LCM there? Well, 4, 8, 12. I'll stop there. For 3, it's 3, 6, 9, 12. There we go. And for 2, 2, 4, 6, 8, 10, 12. It happens to be 12. 12 is the lowest common. Is it 3x plus 4y? Oh, yeah. Is it Friday? It's probably Friday. That's why that happens. Okay. Too many things going on for the small brain here. And so LCM is 12. Thank you, Christine. So the LCM for this one is 12. So we go times 12. Okay. Yeah, I appreciate when you catch something like that because especially it's on a video, right? Then I can correct it right away. So times 12. So I go 1 times 12 is just 12 divided by 4 is 3. So it's 3x. And then watch the negative. Raise your hand and say, I will never forget a negative or a double negative, right? Those are so lethal, right? Like they kind of ruin everything, but you just have to be careful, right? 12 times 1 is 12, divided by 3 is 4. And then equals, right? And I would go 12 divided by 2 first. That's 6. 6 times 5 is 30. And now you've created a fourth equation. So we have 4, but really we just want to work with 3 and 4 moving forward. Except for the verifying part, I would always suggest go back to the original, okay? All right, so we're almost there. Now, the first step is to pick one of the equations and isolate x or y in that equation. But here, there's a bit of a trick to it, okay? I see 3x and 3x. 4y, 4y. I see that, right? So really, what I'm going to do is I'm going to pick the first one. You can pick either one. So in equation 3, I'm going to isolate 3x. Not x, just 3x. So watch what happens. 3x is equal to this 4y, this whole term comes over subtracting. So I end up with negative 4y plus 6. Mr. Durson, could I just isolate x by itself? Yes, you could. It just makes it a bit more complicated when you substitute that into the other equation, but you can. So we isolate 3x, so sub into the other one. We're going to sub into. So watch that we have the 3x here. And since we know what 3x is equal to, it's equal to negative 4y plus 6, courtesy of equation 3, we plug this whole thing into here. Okay, so we end up with, and I will use brackets, negative 4y plus 6 goes there. Minus, right, there's still the minus 4y is equal to 30. And now we isolate for y, because that's all that's left. So negative 4y and negative 4y is negative 8y. And this is what I mean by two steps, right? The 6 is positive, it comes over negative. You can do that if you do the work. So it's negative 8y is equal to 24 positive. Divide both sides by negative 8. Y is equal to negative 3. I will box that in. You found the y component of the solution point, of the point of intersection. Okay. I will back up here. I will stop for a bit and tell you how I'm going to right now distribute my marking. Okay, the marks, how can you earn marks here? Well, I would say if you get 3 and 4, we will give you 1 mark for each. I will give you 1 mark if you've done this. Okay, 1 mark each. Then I will give you another mark for isolating. It doesn't matter which one you picked, right? But if you isolate it, and we're assuming it's correct, and it's all gonna be confirmed once you come up with your final solution, right? So you get 1 mark for isolating in one of these, right? And then we're gonna give you another mark for coming up with the negative 3. And I know for some of you this is gonna be hard to mark because you made a mistake. Use your judgment. What would you give yourselves? Because remember, ACs, right? Like and make a note on it. If you're not sure, I always adjust when I enter it into my system. Okay. Now, the journey continues. Now that we have this, we can sub into 3 or 4 again, right? Like once you have this figured out, you can sub that into either one of these and go from there. Mr. Dirksen, could I use 1 or 2? Yes, you could, but it's going to be a bit more complicated. Okay, just you're going to work with fractions there. So how about I pick 4. Just I'm randomly picking 4 here. So we go 3x minus 4, and y is now negative 3, right? So you substitute that in, is equal to 30. And you end up with 3x, negative and negative, that's plus 12, is equal to 30. And then it's 3x is equal to 18 minus 12. Show your work, okay? Show the steps. It's so much better than rushing and making a mistake. 3x is 18, divide both sides by 3. x is equal to positive 6. We circle that in. You get another mark for that. Okay. Now we're going to verify. I'm going to use the original. I'm going to use the original equations, the original system to do this. Okay, because it could be that you made a mistake when you were rewriting it. Left hand side, right hand side of the very first one, I have 1/2 x plus 2/3 y, and that's equal to 1. Okay, and then I go 1/2, what's x? X is equal to 6, so you plug in the 6 there, plus 2/3 y, and y is -3. So this is really 1 times 6 is 6, divided by 2 is 3. And here these cancel out, right? But you still have that -1. So it's 2 times -1 is -2, right? And that's 1. So left-hand side is equal to right-hand side. Check, right? So this was the first, from the first equation. And then I'm going to do the same thing with the second equation. Left-hand side is equal to, or left-hand side, right-hand side, we don't know if it's equal yet. And it's 1/4 x minus 1/3 y is 5/2. 1/4 x, which is 6, minus 1/3 y, which is -3. We plug that in. Watch the double negatives. Here you can go 6 times 1 is 6 divided by 4. You could get a decimal. We don't like decimals in this course. We keep it as a fraction reduced if you want, because pre-cal goes that way. And applied, you'll be fine going into a decimal because we use our calculators heavily there. So it's 3 and 2. It reduces, right? The 2 goes in here 3 times. The 2 goes in here 2 times. So it's 3.5. And watch this. Negative. These cancel out. But negative and negative is, right, +1. And we know that, right, 1 is 2/2. So it's 5 plus 2. Sorry, 3 plus 2 is just 5/2, right? So left-hand side is equal to right-hand side. Therefore, 6 -3 is the solution. And you get, I would say you get 1 mark. Usually it won't be like that, but you get 1 mark for each verification and another mark for the actually stating the final solution there, 6 -3. So we have 1, 2, 3, 4, 5, 6, 7, 8 marks for question 1. And then we're going to do the graphic method next. Okay. So I'm using this as a lesson at the same time, right? So now we're going to do graphing, right? Graphing method. And now what I'm going to do is I'm going to use the equations 3 and 4 because you want to rewrite everything into y is equal to mx plus b. So actually multiplying everything to get rid of the fractions is the way to go. Okay, use 3 and 4 to rewrite. Okay, so I'm just going to go ahead and copy what I got there. 3 was the 3x plus 4y is equal to 6, and 4, that fourth equation was 3x minus 4y is equal to 30. That's how I'm going to do it. I will now rewrite both of them. Just right beside it, right? because you can go 4y is equal to the 3x comes over subtracting the 6 is already there, and divide everything by 4, and you end up with y is equal to negative 3 over 4, that's my slope right there, plus 6 over 4, which is 3 over 2. And I know this is going to be 1.5, okay? 3 over 2 is 1.5. Sure, you can think of it that way, but leave it as a fraction here. It's 6 over 4 reduced to 3 over 2. And then the next one here is negative 4y is equal to the 3x comes over subtracting. It crossed the equal sign. And there's the 30. Then we divide everything by negative 4. Okay. And y is equal to negative and negative is positive. And 30 divided by negative 4 is negative 30 over 4. And we can reduce this, right? 2 goes in here 15 times. 2 goes in there 2 times. So it's really y is equal to 3/4 x minus 15 over 2. Not an ideal graphing situation, but it can be done. And that's why I wanted you to first use the substitution method, then graph. So here I'm going to go ahead and graph this. So if you want to be safe, if you go 10 in each direction, I can tell you that that's going to do it, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to stop there. 3 and 2 is 5 here. I'm going to label this X. I'm going to do the same thing on the 1, 3, 4, 5, negative 5, right? Keep it there. 1, 2, 3, 4, 5, 6, 7. Sorry, I'm off grid, right? So I got to keep going here. 7, 8. That's going to be good enough. So I'm going to go 1, 2, 3, 4, 5, negative 5. And I'm going to go 1, 2, 3, 4, 5. And this is the y-axis, right? Let me zoom out a little bit. So if you space them out consistently, it actually works out pretty good. The first one has, I know you can't see it on the graph, on the screen, sorry. But the first one has a y-intercept of 3 over 2, which is 1/2, right? So 1/2 here, and you have a slope of negative 3 over 4. Watch carefully up here. You have a slope of negative 3 over 4. That means that you're dropping 3 and you're running 4. So you just got to count by halves, right? So 1, 2, 3. So you're here. If you drop 3 units, you'd be here at negative 1.5. And then you run 4. So you'd be right about there. And then you do it one more time. 1, 2, 3. 1, 2, 3, 4, 5. You should be at 8 here, right? And they do line up as best as you can, at least, right? It won't be perfect. And I extend my line. And this is the line 3x plus 4y is equal to 6. Right? You can do this, right? And then the next one has a y, what's 15 over 2? That's negative, right? 15 over 2 is negative 7.5, right? It's 15 split in half. So negative 7 is here. Negative 7.5 is right there. That's my starting point. And my slope is positive 3 over 4. So I'm going to go 1, 2, 3, right? You get to here. And then you run 4. And I'm just looking up. That's the 4 mark right there. And then you do this one more time. 1, 2, 3. 1, 2, 3, 4. You're here. Right? And then we graph that line. And this is the line 3x minus 4y is equal to 30. And if you think about it, the point of intersection is 6, almost negative 3. We know it's, right? POI is 6, negative 3. I didn't ask you to verify because you already did, right, in the first one. So how am I going to mark this? I will tell you. You get 1 mark for rewriting the first equation. You get another mark for rewriting the second equation. You get 2 marks for a graph that is completely labeled, including the point of intersection. You have your arrowheads, you have the lines labeled, all of that. If you have all of those components, you get 2 out of 2 there. So this question right here is worth 4 marks. Okay, the question 2 is worth 4. So 8 and 4, we are out of a total of 12. Okay. So total is 12. So give yourselves a mark out of 12, and then you'll submit it. So go submit it now, and then we want to spend the last little bit. Sure. I will just stop this here.